Good morning. This is Miss Billerbeck. Let's talk about 14.2, completing the square method. Now we're going to take a little baby step into this and look at, well, what happens when we have something that's squared and it equals something? How do we find out what x is? Well, if we take the square root of x minus 1 squared, and we take the square root of 36, we can find the answer. Now, there's something we need to know, we need to think about. Okay, so we need to think about if we have -3 squared and 3 squared, don't they both equal the same thing? Okay, they do. So we probably, when we do that, we might want to put a plus or minus right there. Okay, so we have, when we take the square root of something that's squared, it frees that whatever's being squared from the radical. So we have x minus 1. So what happens here is we have plus or minus, and this ends up plus or minus the square root of 6 times 6. So 6 times 6, there's 2, there's a pair. It's a square root house, so the 6 gets to come out. Okay, so we use an additive inverse, and we add 1, and we get x equals 1 plus or minus 6. All right, so what that means is I have x equals 1 plus 6, which is 7. 7 minus 1 is 6. 6 squared is 36, so that works. But the other one, let's look at that one. So that's x equals 1 minus 6 is -5. So -5 minus 1 is -6, and -6 squared is 36. So we have two solutions. We have -5 and we have 7. They both make 36 when they're squared, and with x minus 1. Isn't that crazy? Okay, so let's do the same thing here. So we're going to take this x plus 4, and it's squared, so we're going to take the square root. We have to remember that when we take the square root of 23, this could be a plus or minus. So this is a 23. Let me just write that 2 a little bit better. Okay, 23. So we have x plus 4 equals plus or minus the square root of 23. So we can subtract 4 from both sides, and that gives us x equals -4 plus or minus the square root of 23. Now, if we look at the square roots, square root of 23 is between the square root of 25, and it's also between the square root of 16. So it's between 4 and 5. Okay? But it's much closer to the square root of 25, so I'm going to make a quick estimate that this is going to be about 4.8. Okay, so that'll help me when I'm trying to find this. So it approximates to 4.8. Okay, so what that means is I have x minus equals -4 plus 4.8 Okay, so that gives me x equals 0.8 when I subtract 4 from 4.8. Or I have x equals -4 minus 4.8. So x equals -8.8. So my solution set for this with an approximation is -8.8 or 0.8. Okay, so that would be my solution set for this. All right, if we test it out, we should come pretty close. So let's just see. Okay, so if I have -8.8 plus 4, and that equals that, and then I'm going to take that number, and I should probably, let's see if I can square it. Let me delete this really quickly. I'm going to put in some parentheses, and then I'm going to take this and in parentheses because I need that negative. I need this negative right here. I need it included in the square. Now I'm going to square it. It should come out. There we go. Pretty close to 23. Okay, so let's try the other one. So we had 0.8. So that's just 4.8. So 4.8 squared. And that's pretty close to 23 as well. So we did good. We did well, I should say. That's the proper English. We did well. All right, so let's look at completing the square now. So we've been using the square for the diamond box. So we are going to actually look at the mechanism for completing the square. Okay, so we know that x times x is x squared. And x times b over 2 is b over 2x. And this is also b over 2 times x. And then if we square this, this is b over 2 squared. Okay, when we add this up, we see that these are the same thing. So we have x squared plus b over 2x plus b over 2x plus the quantity b over 2 squared. Since I have two of those, that's twice b over 2, which just is b. So I have 2 times b over 2x plus b over 2 squared. Okay, so that cancels, so I get x squared plus bx plus b over 2 squared. Well, that just ended up equals x plus b over 2 squared. So we have a rule here that ends up that if x squared plus bx plus b over 2 squared, if we have that perfect square trinomial here, then this is going to equal x plus b over 2 squared. So that's what we're going to be doing. This rule right here is what we are going to be doing. That is completing the square. Okay, so that's a very important rule, completing the square. Okay, x squared plus bx plus b over 2 squared equals x plus b over 2 squared. So we're completing the square. We're trying to find this term here, this b over 2 squared. So a lot of times we're given b, so we divide it by 2, and then we square it. And that's how we find this term when we're trying to complete the square. All right, so let's figure out how we would complete these to make them terms. Let's complete this by adding that missing term, which would complete the square. So what we're missing is there's a 1 right here. So this would be plus -1/2 squared, because we divide this by 2 and then we square it. So the perfect square trinomial would look like this. Because 1/2 squared is 1/4, and a negative times a negative is a positive. So this is the missing term, 1/4. Okay, if we take this, we have 4/5 times 2, because we have to divide that by 2, squared. Okay, so I just divided 4/5 by 2 by just multiplying the 5 by 2. So what this ends up being is w squared plus 4/5 w plus, and then we have 4/10. But wait a second, 4/10, that's the same thing as if we reduce this. That's the same thing as 2/5. So let's do 2/5 squared. Okay, so let's never forget to reduce before we do some squaring, because that'll make a big number even bigger and harder to find those factors that to reduce and simplify the fractions. So here we go. So 2 squared's 4 and 5 squared's 25. So our missing term was 4/25. Okay, so that's what we had to add. All right, so now let's do this for real. Okay, we're going to solve this by completing the square. So first, I think I'm missing a little something here. So let's put this little, this should equal a 0 right there. Okay, so we're going to solve using the complete the square technique. All right, so first of all, I've got x squared minus 3x, and now I'm going to add 3/2 squared, but I can't just add 3/2 squared, so I'm going to subtract 3/2 squared, and then I have the -5 equals 0. Okay, so I really haven't done anything to the equation here. I added 3/2 squared and I subtracted 3/2 squared, but I took this, oh, and that's a negative. Not that it makes much difference because it's getting squared. Okay, so I took this -3, divided it by 2, and then I squared it to complete the square. Okay, so what I have is I have x squared minus 3x plus 9/4 minus, let's see if I can make some room here, minus 9/4. That would be this one, minus, and let's get this one in terms of 4s, since we've got all these 4s. Okay, and then 5 times 4 is 24 equals 0. All right, so this is my square right here that I'm completing. And this is things that I don't really need. So what I'm going to do is, since this is a perfect square trinomial right now, I can say this is x minus, because I have a minus sign here, and that's 3/2 squared. And then this is a minus 29/4 equals 0. Okay, I'm going to use the smaller pen now. So what I'm going to need to do is use an additive inverse and take that 29/4 and add it to both of these sides. Okay, so let's move over here. So now I have x minus 3/2 squared equals 29/4. All right, well, we can use what we first learned. We can take the square root of both sides and add a plus or minus. So we have x minus 3/2 squared, and we're going to take that square root like that, equals plus or minus the square root of 29/4. Okay, so that gives us x equals, whoops, sorry, not equals yet, x minus 3/2 equals, and then we have the square root of 29/4. So 29 is close to 25, 4 away from that. And to 36, the square root of 36 is 6. Square root of 25 is 5. So this is 7 away from the square root of 36. It's only 4 away from square root of 25. So I'm going to say this is about 5.3. So let's look at what is the square root of 29. 5.38. Okay, so it's a little off. So let's say 5.4. Okay, so I have plus or minus 5.4 divided by 4, and we're going to take a, oh wait, I don't want to do that just yet. Let's keep it the square root of 29. Okay, but let's note that that's 5.4. Okay, so we have square root of that. So the square root of 4, the square root of 29, and the square root of 4 is 2. So I have plus or minus the square root of 29 and the 2 here. So what I need to do is I have x. I'm going to add 3/2 to both sides. Okay, and that gives me x equals, and I'm going to have 3/2 plus or minus, and now we can go back and say that's 5.4 over 2. Okay, so what that gives me is, I think what I'm going to do is put this problem on another page so we can have some more room here. Okay, so let's move this and so we have some more room to play here. Okay, all right, so we have that. So that gives me x equals 3/2 plus 5.4 over 2, which is 8.4 over 2, which is just 4.2. Or we have x equals 3/2 minus 5.4 over 2 equals negative, and that's going to be 2.4 over 2, which is negative 1.2. So we have two answers here. We have negative 1.2 and we have 4.2. Okay, so there we have it. So those would be our two solutions if we did everything correctly. All right, that's a lot of work. Okay, let's do it on this page. The next problem. Okay, here we go. So first, when we have something like this, what we have to do is get this in terms of with x is 1. So we need to divide everything by 2, including 0. So that gives us x squared minus 9/2 x plus 3 equals, and 0 divided by 2 is still 0. Okay, so we're going to complete the square. We have x squared minus 9/2 x. And then I have plus, and I'm going to make that 9/4 because I'm going to divide that by 2 by doing 2 times 2, or let me just do that for you. So it's 9/2 times and divide by 2 again, squared. But I can't just do that. I have to also do this, so I'm not really changing the equation. And then I have plus 3 equals 0. All right, so this gives me my perfect square trinomial. So that's 9/4. So that gives me x minus 9/4 squared. And then this is minus 9/4 squared. So that's 81. 9 squared is 81. 4 squared, 16. And then I need to get this in terms of 16 as 3. That's not going to be pleasant. So I have 16 over 16 equals, so 3 times 16, well, that's 18. Carry a 1 is 48. Well, that wasn't that bad. So equals 0. So I have 81 and 48. So they're different signs, so we can just subtract them and remember that the bigger number is negative, so our answer is negative. So we borrow, we get 33. Okay, so we have x minus 9/4 squared minus 33/16 equals 0. Now we can move it to the other side. So we add 33/16 to each side. Okay, so we have x minus 9/4 squared equals 33/16. Now we're going to take the square root of everything and put a plus or minus here. So I have x minus 9/4 equals plus or minus the square root of 33 over, and the square root of 16 is 4, because this equals this plus or minus the square root of 33 over the square root of 16. So if you missed that on the last example, that's how I'm getting this bottom one. It's the square root of 16 like that. All right, so now let's add this 9/4 to both sides. All right, let's erase this and make some room. So if we come back over here, we get x equals 9/4 plus or minus the square root of 33 over 4. Look at that, they have the same denominator. Isn't that awesome? Okay, because we can't add fractions unless they have the same denominator. So we have to make an estimate of what is the square root of 33. So it's closer to the square root of 36, which is 3 away, than to the square root of 25, which is 5, which that is 8 away. So I would say this is closer to 5.8. So that's the guess I would guess. So take the square root and 33. 5.7. Okay, I was close. Okay, so 5.74. Okay, so we have x equals 9, and they're all over the 4s, plus or minus 5.7, and it was 5.74, so let's put it there. So it's only 0.06 off. Okay, so we have x equals, so this is going to be 9 plus 5.74 over 4, which is x equals 14.74 over 4. Okay, and let's just, I'm going to do that quickly on my calculator. 14.74 divided by 4 equals, that approximates to 3.7. Okay, or we have x equals 9 minus 5.74 over 4. Okay, so let me just do that one quickly on the calculator. 9 minus 5.74 divided by 4. And that gives me 0.82. Okay, so our solution set is 0.82 and 3.7. So I probably should just leave that 0.8 because I should have them to the same degree. So 0.8 and 3.7 for my two answers for that. So again, that'd be a little hard to check, but you would just plug that back in here to check. And those should work out very nicely. So that is completing the square. What fun, huh? All right. Have a great day. Bye-bye.